Hello. In this Labtube, I will solve an example about powers of square matrices. The matrix is 1, 2, 0, 1, and the question says find A2, A3, and in general, AN. At the beginning, questions like this might be confusing. What does it mean to find AN? But what it says is that find A2, A3, A4, first one few of them, like 2, 3, 4, and then you will find a pattern and then write down that pattern as power of AN for general N. Well, let's see what is A2. A2 means you multiply A to A, and here I have 1, 2, 0, 1, multiply 1, 2, 0, 1. Well, this is 2 by 2 matrix, 2 by 2 matrix. The result is 2 by 2 matrix. The first entry is this multiplied to that. So 1 times 1 plus 2 times 0. The second entry of the first entry of second column is this times that. So 1 times 2 plus 2 times 1. 0, 1 times 1, 0. So 0 times 1 plus 1 times 0. And this times that. It's 0 times 2 plus 1 times 1. Well, OK, I have 1 plus 0 is 1. This is 0 plus 0 is 0. 2 plus 2 is 4. This is 1. This is A2. That's good. A3. A3 is multiply A 3 times to itself, but we already multiplied it to itself and we found A2. So I can multiply A2 to A and I get A3. So I have 1, 4, 0, 1 multiplied to 1, 2, 0, 1. This is the first entry of first row, first column is this multiplied that. 1 times 1 plus 4 times 0. 1, this times that, so 1 times 2 plus 4 times 1. This times that, this is 0 times 1 plus 1 times 0. And this times that is 0 times 2 plus 1 times 1. Well, the result is this is 1 plus 0 is 1. This is 0. This is 2 plus 4 is 6. And this is 0 plus 1. This is 1. Well, maybe I need one more to see what is the pattern. Here, maybe you already noticed some pattern. For example, the diagonal entries are not changing. They are always 1, 1, 1, 1, 1, 1, 1, 1. And you have 0 in 2, 1 entry. So 0, 0, 0 in all powers. That's a pattern. What about other things? So other thing, for power 1, I have 2 here. For power 2, I have 4. For power 3, I have 6. Then it seems that whatever the power is, you multiply by 2, you put it here in the entry 1, 2. Let's check it for A4. So for A4 means that you multiply A 4 times to itself, but I already have A3, so I can multiply A3 by A and find A4. So I have 1, 6, 0, 1. Multiply 1, 2, 0, 1. Well, 1, 6 times 1, 0. So 1, 1 plus 6 times 0. 1 times 2 plus 6 times 1. And here, 0 times 1, this is 0 times 1 plus 1 times 0. And this is 0 times 2 plus 1 times 1. Well, let's see the patterns that we found, if the patterns that we found is correct here. The first entry, 1 entry is 1 again. This is 0, 1. 2 1 entry is 0 again. 2 2 entry is 1. And look at 1 2 entry. It's 2 plus 6, 8. Well, it seems that pattern is correct. You can do, if you know how to prove, and you know the techniques for proof, you can do induction and prove that, well, a to the power n, as our examples show, will be 1 1 on the diagonal, 0 in 2 1 entry, and 1 2 entry is 2 times the power. 2 times 1 is there. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So I have 2 times n. Well, that means, like, for example, if you're looking for a to the power 10, you have 1. 2 times 10 is 20, 0, 1. Or if you have a to the power 2017 is here, I have 1, 0, 1. 2017 times 2, so it's 4034. Well, there are other questions similar to this in your book. Section 3.1, question 36 and 35 are of the same nature.